It's all part of the deception. I've spent 30 years of my life believing that we were on a spinning globe. We are told that the Earth spins at 1,040 miles per hour, while the Earth travels around the Sun at 66,000 miles per hour. Meanwhile, the whole solar system is going inside the Milky Way galaxy at a speed of 490,000 miles per hour. And finally, the entire Milky Way galaxy is darting through infinite space at over 1 million miles per hour. Most people believe this, and yet every experiment ever conducted has failed.
The Earth. Is it really just a big ball floating in space, spinning on its axis at 1,000 miles per hour, hurtling around the Sun at 67,000 miles per hour, whizzing through the Milky Way at a milk-curdling speed of over 500,000 miles per hour, and warp driving through the heaven at over 500 million miles per hour? And what about the Sun? Is it really 93 million miles away and close to 1 million miles in diameter with a circumference of nearly 3 million miles? Or, the Sun isn't big, but is very small and very close, not illuminating the Earth from 93 million miles, but is illuminating locally. And maybe everything, the Sun, Moon, and stars, are not far away, but circle overhead relatively close. In this video, we're going to explore the latter option, and at the end, we're going to reveal startling evidence through the use of time-lapse photography that the Sun cannot possibly be 93 million miles away, but is in fact very close, illuminating locally as it traverses our Earth. Oh man, and watch how this Sun comes at you. Boom! I mean, come on. And that's all perspective. If you look at jet trails, Google Images, you'll see them. They start out low at the horizon, they come up overhead, and then they go down to the horizon. Perfectly explains what the Sun would do. Here it is going overhead. I love time-lapse. Look at this. Okay, back to the Copernican principle, and this is what they tell us. The Sun is 93 million miles away. Now, I'm going to show you evidence through sunsets that shows the sunlight following the Sun over the horizon, and it shrinks as it goes over. Now, there's no way it would do that if the Sun is 93 million miles away. Above the clouds, we're only maybe a mile or so up, and if the Sun appears to be closer to the camera, well, that means it's probably much closer, because if the Sun were 93 million miles away, a mile closer wouldn't make any difference at all to its visual appearance. Without further ado, we're going to start talking about, and I'm going to start showing you the time-lapse of sunsets that clearly show the Sun is close and illuminating locally. Here we go. Alright, and here are a couple of time-lapse sunsets, and just like the sunrises at the beginning of this video where you could see the Sun coming at you, not maintaining any 93 million mile distance, here you can also see the Sun moving away, but the Sun is moving away from you. Okay, these next three slides, the Sun is almost set already behind the horizon, but watch as the sunlight shrinks and follows the Sun. It's definitely a locally illuminating Sun, not far away, not very big, and definitely not 93 million miles away. In the video, I showed you this one and how it's circling over the Earth, and watch it sweep to the right like a bowler bowling it in there for a strike. Now I want you to pay attention to the way the light follows the Sun. The sunlight's going to shrink as it follows the locally illuminating Sun. Watch this. See it shrinking, following the Sun? You do not get that if the Sun is 93 million miles away. The entire horizon should fade evenly, just like this supposed shot taken from space of the Earth. You can clearly see the way they depict it. They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we've seen in the footage so far. The sunlight shrinks and follows the Sun over the horizon. So these time-lapse sunsets are definitely the nail in the coffin for heliocentrism. But this particular one here, shot from above the clouds from this observatory, is the final nail in the coffin. Look at how the Sun just shrinks and the light shrinks to nothing. That cannot happen, as I showed you in the Sun illuminates the entire Earth, which it does, from 93 million miles away. It has to. You don't get this isolated look at the sunlight trailing the Sun. That's only possible with a small Sun, close, not very high, illuminating locally. I mean, this isn't proof to you, then you gotta take the blinders off. Okay, and finally I want to show you some examples of local illumination, or a city in the background. Las Vegas, is one of them. You can see the stars going down, so you know that's not the sun. That's the glow of Las Vegas. That's local illumination. One here you see two lights. Obviously we don't have two suns, but these are two cities lit up, and it's just to show it looks just like the sun going over the horizon. That's the point of me showing that. That's local illumination at work. The sun is not 93 million miles away, because if it was, the entire horizon would fade evenly, and the entire horizon would fade at the same time. Not what we see here, which is the small sun cruising over the Earth and the light is following it. Case closed. Hey everybody, this is a video about the sunbeams or the sun rays that come through the clouds called crepuscular rays. And what I'm going to do here is prove in this video, with a series of proofs, beyond a shadow of a doubt, that the sun is close and the sun is small. First I'm going to show you an experiment I did with the sun rays. That's very solid proof that the sun is in fact close and not very big. And then I'm going to refute Wikipedia's account of these crepuscular rays. They say that these rays are due to perspective, and that in fact they are, for all intents and purposes, parallel lines from a sun that's almost 1 million miles in diameter. But the fact that we see them splaying out, they say that that's due to perspective. I'm going to show that that's impossible. And then number 3, I'm going to show that it's actually, when you take a look at this picture of the crepuscular rays, that actually perspective is missing from this photo, if in fact the sun were 1 million miles in diameter and 93 million miles away. The heliocentric model is in trouble. We see the sun rays splaying out from the clouds as though it were a close sun and not a faraway sun. Well, you can see when it is far away, the light beams are parallel and they don't splay out or diverge from the clouds. So then I got a little bit more sophisticated. I went inside and I cut some nicer holes in another cardboard. You know, my budget went up. And here they are, and I put some CGI here. I put some beams in there, and you can see they are dead straight, no splaying out. And then you can also, there's a part here where I have it up overhead, and I had the same results, no splaying out. So this is the example of the faraway sun, that the rays, this is what we should experience coming through the clouds. The rays from a sun that's almost 1 million miles in diameter and 93 million miles away, when those rays get here, they should be parallel and dead straight. But we don't see them as dead straight. We see them splaying out or diverging from the clouds. Something's not right here. Okay, here I am inside. Notice I got my light close. Look at already, you can see the light splaying out. You see that? You can see the circles on my piece of card. Those are the original size of the holes that when I was outside, they lined up perfectly. Here, you can see them completely splaying out. And if I put the rays on it like this, the sun rays, and that's not even as splayed out as they got, it's just that the cloud is in view. And I want you to be able to see the cloud, which is my cardboard with the holes cut out of it. That way I could line up the rays. But as you can see, when I moved up a little bit off the floor and put the light even closer, the rays really splayed out. So I just wanted you to see that. Okay, so there you go. There's hard evidence that when the light source is close to the clouds, the light will diverge. The dispersion pattern you can see when I was outside, the dispersion pattern remained the same, meaning the 5 holes that I had, like that, stayed exactly the same, and that's a faraway light source. But when the light source was close, they splay out. That definitely supports a small, close sun. Okay, let's analyze this claim that science and Wikipedia makes, that crepuscular rays are due to perspective, that they're actually very close to parallel lines. For all intents and purposes, they are parallel, coming from a sun that's almost 1 million miles in diameter, but we don't see them parallel coming through the clouds. Those crepuscular rays are angled outward. They splay out. They're diverging from the clouds. And Wikipedia is saying that that's due to perspective. And Wikipedia also uses railroad tracks like these. And they say, see how these converge at your horizon, or they diverge from the perspective of the sun outward? And they're saying that that's what's going on here. Okay, so we need a quick little review of perspective. Notice in this long hallway, all parallel lines and planes angle to the eye level or the eye position of the observer. Notice that the side walls angle in, those are parallel lines to one another, and the ceiling and the floor are also parallel, but notice how they angle toward each other and they come to your eye level. You have an X, Y, and Z axis. So the railroad tracks would fit your Z axis. That's going away from you, and those lines, yes, they converge. But the sun, and especially when the sun's overhead, would be bombarding us with huge vertical parallel lines or parallel rays. Yet, we don't see any of that, ever. So what I'm going to show you here is that this claim that these crepuscular rays is due to perspective is not true. It's impossible, because perspective will not converge or diverge or splay out lines or planes that are parallel to one another, that are perpendicular to the viewer or his Z-axis. So like in this picture of the railroad tracks here, the lines going away from you, that's I did with the green line, that's the railroad track, that's obvious. And right from the get-go, they start to converge. Now those are parallel lines, but yet we never see them as parallel. They're always converging as they go away from you. Now the black poles that I have going down the side of the railroad tracks are also parallel lines to one another. But notice that they stay parallel. They don't lose their parallel orientation. They may get shorter and they get smaller, but they don't change their parallel orientation, these vertical lines, because they're perpendicular. This is why invoking perspective to explain the crepuscular rays doesn't work, because perspective does not splay out these vertical lines. Whenever the sun is overhead, we should see vertical parallel rays everywhere, and yet we don't see them. So perspective as an explanation for this is invalid. What we see is the rays emanating from this omnidirectional sun. The rays fit the size of the sun, and the angles of the rays off the sun also fit the size of the sun. But they shouldn't fit the size of the sun if the sun is in fact almost 93 million miles away, a million miles in diameter. The rays should be huge and the sun small. So that's telling us that the sun is in fact close. And let's go back to what Wikipedia said. Wikipedia says that the rays from the sun are in fact parallel lines, but we don't see them that way because of perspective. Perspective displays them out. Okay, look at this picture. I put these rays in. Okay, so this is what's really going on. Wikipedia says, they say that rays are really parallel, and they would be from a million-mile diameter sun. But this is what our eyes do through perspective. It displays it out. Okay, here's another one. They say this is how they really are. They're vertical and they're parallel, but our eyes splay them out like this. Okay, so then why doesn't perspective take these telephone poles and splay them out like this? We don't see that, do we? Why doesn't it take these buildings and splay them out like this? They're vertical and they're parallel. Well, because what we see, the crepuscular rays, is not due to perspective. It's just due to the nature of an omnidirectional light source with the light coming out in all directions. And it's coming from a small sun. It's impossible that this sun is a million miles in diameter. So then if it's not perspective, these crepuscular rays are not due to perspective, as Wikipedia and science in general claims they are, then what are they? Well, it's very simple. All they are is radially propagated light. Or another way of saying it, light rays emanating out from a common center, like any light. And I understand that the light rays coming off the sun looks like perspective. It shares the common trait with perspective. All the lines and planes converge at a point in the distance called your vanishing point. The sun also has that look, where it looks like the rays all converge at a point in the center of the light. Actually, the light rays are emanating out from a common center. Okay, that's all it is. And so, as we've already proved, that perspective can't explain the crepuscular rays, because where are all the vertical parallel sun rays then? They don't exist. Okay, so next I'm going to show you with streetlights and sunlight and how they look exactly alike. Okay, let's take a look at some light rays. Let's look at how the sun and a street lamp look the same. The one on the left is a street light, and the one on the right is the sun. Okay, notice that the light source and the rays match one another, and with the street light, that light is here on Earth, right? It's right there on your street, and those rays look in proportion to that light. They're also here on your street or wherever you see that light. The sun, they're telling us, is actually far away, but the light rays are close. Street lights also have crepuscular rays, just like the sun does, and you know what? They look identical. Let's have a look. Here on the left, that's a street light, and those are crepuscular rays coming off of that street light, and they look identical. They are in the same proportion as our sun and its rays. And you can't say that that's perspective, because they're right there, and as we've seen, perspective can't explain those rays anyway. So those rays are nothing more than radially propagated light. In other words, it's light coming from a common center. That's all. And look at this one. The left one is a street light, the one on the right are sun rays. They are both in proportion to one another. The light source matches its rays, which indicates that they're both local. Okay, and this street light is here. We know it's here, and we know those crepuscular rays are here. There's no fooling us and telling us it's 93 million miles away or a million miles in diameter. And it looks just like the sun, that they're telling us is far away and huge. Same here. Same as what we see in the sky. The sun matches the sun rays. But in the heliocentric model, with the sun that's 93 million miles away and almost a million miles in diameter, the rays should be completely out of proportion, like this. You know, we shouldn't maybe even see the sun. Maybe the sun should just be a blob of light on the other side of our lit-up atmosphere from these huge rays. I mean, we see the sun like it's in our atmosphere, like it's close, but it can't be, according to the heliocentric model. And next, I want to show you how, in this photo, perspective is actually missing. And what's ironic is, the very linear perspective that they tried to invoke to explain this photo is actually missing from this photo, for the heliocentric model to be true. And they invoked perspective to describe or explain these crepuscular rays, the fact that they're splaying out from the clouds. Because they had to invoke perspective or something, because this picture doesn't work for the heliocentric model. This picture of these crepuscular rays is a problem for their model, because the problem is they've invoked perspective, but perspective doesn't work because, as I've already showed you, it doesn't explain the parallel vertical lines that we should see all over the place. Perspective will not splay those out. These vertical rays should be everywhere, but we don't see them, all right? Far away, when the ball gets to you, it's going to be the size of a soccer ball, right? This is proper perspective. This is the perspective we're not seeing when we look at the sun. The sun that we see in the sky is close. Okay, here's a train leaving a station far away down the tracks. Also analogous to the rays leaving the million-mile diameter sun. Okay, the rays would be massive just like the train is massive compared to that little train station. Right? That's proper perspective. Now look at these shafts of light coming from the sun, the rays. The sun on the right here, each of its rays that you see coming off the sun would be about 100,000 miles wide. You could fit 10 Earths side by side in that ray. Okay, so when we look at these rays, they're not 100,000 miles wide, and they're diverging out from a small sun that we see in the sky. I mean, that proves right there, the sun's close and small. And thank you so much for watching. There's only one thing left to do. Let's kick the ball out of here. Take care.